So as we said last time, we had two strategies. Now we're going to have a third. So this is called the first half strategy. And this comes from noticing that two students actually only have a 25% chance of winning with the random or random with memory strategies. They could improve this to 50%. So why? What's going on here? So 25% chance happens because each student, let's say in a two student game, comes in, there's two boxes, they choose one. They have a 50-50 shot at getting it. So each one has a 50-50 shot. They don't, influence each other in any way. So 50% times 50%, half times half is quarter, 25% chance of them both getting it right. There's also three other options. They both fail. The first one succeeds, or the second one only succeeds. Those are your four possibilities. This is the first strategy where we could talk about what happens if they plan something ahead of time. So if they decide beforehand which box each will open, let's say student one just says, I'm going to open box one. And student two is like, no problem, I'll open box two. Notice what's going to happen. They're either going to both succeed or they're both going to fail. So there's a 50-50 shot of box one containing the number one in it for student one, in which case they win. If they win, there's no way student two can't win. Student two has only one option left, and that other number's got to be in that box, right? So, more generally, if you have the first half of the students all open the first half of the boxes 1 through 50, and the second half of the students all open the second half of the boxes, 51 through 100, just have them fly through. The first half, open the first half, second half, open the second half. If the first half happen to win, there's no way the second half can't win. You've basically said if the first half won, the numbers 1 through 50 happen to be mixed up in the boxes 1 through 50. None of them happen to be in the latter boxes, which means the numbers 51 through 100 are all in the second half of the boxes. All the second half of the students are going to open them. They're all going to find their number. They're all going to win automatically. So this actually drastically increases the chance of people winning. Now, when I say drastically, it's still really, really terrible for 100 boxes, because what's the chance of all 50 numbers happening to be in the first 50 boxes and not any of them in the latter half of the boxes? It's not great, but it is better. So the reason why it's better, notice this, about just like we did with the two students where basically they either both succeed or they both fail, right? You're kind of piling up successes and failures on top of each other if you do good coordination. Obviously, you could coordinate in ways that make your life terrible. Like if student one and two are like, we're going to coordinate, we're both going to choose box one. You have a 0% chance of winning because one of you is going to definitely fail. So again, you have to do the right kind of coordination, but that's kind of the trick of this problem. If you can coordinate in a way that piles up either all the successes kind of pile on each other so that if one succeeds, more than one succeeds, or if one of them is going to fail, they're all going to fail. Like this actually gets us a better chance of winning by not having the options where like only one student wins, but the other one fails. If we eliminate that possibility, we have a better chance of all the students winning. So that is the plan. Have the first half of the students open the first half of the boxes, have the second half open the second half of the boxes. So from that, we'll go back to our code and we'll actually code that up as a new function. So let's code up this third strategy. I'm going to come down here to the bottom. I'm going to make a new function and I'm going to call it choose one half of boxes. I'm going to give it the same exact inputs as the other two strategies that we have. Remember that because of our choose box function that we're always calling with the same inputs regardless of which box function it actually we're selecting, I need all the inputs to be the same here so that the function can be called without trying to give different inputs in different cases. That would be really awkward and we'd have to have if statements and more complicated things here. But this allows me just to switch out the function. As long as the inputs are the same, I can just switch out the function and get a different strategy. So that's what I'm doing. Now, in this case, choose one half of boxes ends up needing both inputs, so we'll be okay. So remember, we're going to have the first half of the students open the first half of the boxes, second half open the second half. So let's actually figure out what halves the students are. Pretty simple. Let half students equal num students divided by 2. Yay. And if the student number is less than or equal to half students. So if I'm on students 1 through 50, half students here being 50 if number of students was 100. If half students is 50, then, and student number is somewhere between 1 and 50, then I want to just return which box am I choosing, right? I'm just going to choose box I plus 1. Notice there is no S thing yet. Variable yet. We're going to deal with that in a second. But notice I'm returning box I plus 1 because remember that I is going between 0 and boxes to open in this case is 50. So it's going 0 to 49. It's stopping at 50. So the idea here is that I is 0 to 49, but we want to return open box 1 through 50. Like that is what we want to return. So we're always saying, okay, go back up 1. Box 0 is actually box 1. Box 49 is actually box 50 in terms of the box number that we want to open. Yes, the position in the array is 0 to 49, but we always return here which box we want to open as a number between 1 and 100, or 1 in the number of students. Here. Yeah. So notice choose box function was always returning a random number between 1 and 100, not between 0 and 99. So we're going to keep with that. If S is not less than or equal to half the students, that's the other option. Return I plus 1 plus half students, right? I want you to, instead of opening boxes 1 through 50, I want you to open boxes 1 through 50 plus the number of, the half number of students, which is 50. So 51 to 100. So instead of 1 to 50, we just shift it over to 51 to 100. So the second half is what we're calculating here. Now, as I said, notice I need this piece of information. Which student is making the choice? I've never needed this information in the other two choosing functions, but I do need it here. So I'm going to actually have to have this as an input to my function. And if I have to have it as an input to this function, I have to have it as an input to all 3 of my strategies, even though they're not going to use it. That's fine. We've done this before. I just also need to pass it in up here to my choose box function. Notice S, the student number, is given here, right? Because we need to know, we already needed to pass that in up here to play one game per student, just to know whether the box contents actually equal the student number, right? If student number 3 is choosing and the box contents was the number 3, then yay, they won. So we have to also pass it into the choose box function here to say if it's student 3, make sure you return, we're going to choose box 3. And if it's student, we're going to choose I plus 1. Like if they're choosing the very first box, they're going to choose box 1, box 2, box 3, all the way through 50. And if their number is 53, then they'll fall down here and they'll choose box, when I is 0, they'll choose box 51. Then as I becomes 1, 52, 53, 54, 55, as I keeps increasing. So we have a useless variable in 2 of our strategies, but that's fine. This one needed it, so we pass them into every function, and if you need this information, good. If you don't, ignore it. And that's how we implement our choose 1/2 of boxes function. Now, we haven't actually called it yet, so let's do that next. To do that, we're going to just scroll back up here to our place where we're choosing our box function based on the strategy. Notice I've already got the strategy. I've already got this if statement here with the choose box function. I just need to add one clause to this, right? So I'm going to say else if some new thing, i.e., I'm just getting the structure right here. Else if some new thing, do some more stuff. Otherwise, continue to show invalid strategy if we didn't get it right. So what's the new thing? Strategy equals, well, something. What's something? I haven't added that option yet. Okay, let's go do that. Up here in the HTML, I'm going to say option value equals, let's call it first half. And then this is first half is the text that will show, and then close the option tag. Great. So now if strategy is first half, I come back down here and use the same value as here. My choose box function equals choose, I'll just copy it and paste it from down here. I just need this name, right? Choose 1/2 of boxes. Do that. So I choose that function to use as my strategy, as my choose box function in my playing one game and playing one game for student, all that stuff. This choose box function now has the 1/2 choose 1/2 box function being passed down to it if I select the third option here, which is first half. Okay, and that works. Like, I mean, I can't tell that it works yet because it's still a useless strategy for 100 students. But let's try a smaller number of students. Let's try 4. So remember, random was bad in the 3% range to 3 point something 4 maybe. Random with memory was a little better. We're getting 5, 6s, a lot of 6s in here. Let's try first half. Wow, that's a lot better. We're getting a 16% chance of winning roughly. This is close to 1 in 6, like 16.6 repeating would be a 1 in 6 chance. So like we actually have not a terrible chance of winning if we have 4 students now with our first half strategy. Decently better than the 6% that we were getting before. Why is it so much better? Again, it has to do with the first half of the students just choosing the first 2 boxes in this case. So student 1 and 2 go in there and choose box 1 and 2. Maybe it works, maybe it doesn't. But if it does, if 1 and 2 happen to be in the first 2 boxes, either as 1 and 2 or 2 and 1, they win. And then that means students 3 and 4 will automatically win. They'll either be a 3 or a 4, or a 4 or a 3. Those are the other 2 options. So this ends up giving you a roughly 1 in 6 chance. Well, it gives you a 1 in 6 chance of winning. And that's why this is so much better. Again, if we go up to like 8 with random, you can see we are barely getting any chance of winning. We're getting a bit better with random with memory. But with first half, we're actually getting above 1%, which is definitely better than random with memory. So that's our third strategy. There's one final strategy we'll cover that is way, way better. And even is way better with 100, which again, first half is still useless. With all of these, give you no chance of winning, no matter how. Like you could do this a few million times and you wouldn't get a 1. Wouldn't either, because it's just that bad of odds. Okay, so that'll conclude this part, and we'll continue on in the next part. Thanks. Have a good one.